Welcome to this SolidWorks tutorial, guys. In this tutorial we will be designing this part and we will be performing the simulations and we will be seeing the factor of safety and the most critical areas of this part as well. So let's begin. Click on part and click OK, and after that change the background to plain white from here for better visualization, and from here make sure that you are working in mmgs, or if you want to work in inches then you need to select IPS. Click on top plane and click on sketch, and here select the corner rectangle and at this origin make here a corner rectangle like this. Now let's define it. For that, select smart dimensioning tool and here specify the length of this line as 160 millimeters and the length of this line as 90 millimeters. Now we need to select the sketch fillet. So here select the sketch fillet and select these two corners only and define the radius for this sketch fillet as 25 millimeter, and as you can see it from here, this 25 sketch fillet has been applied. Now go to features and select extruded boss base. Here select blind for direction 1 and 10 millimeter extrusion is fine. Check this box from here. Now we need to select this back face, this one, and click on sketch. Select a line tool and make here a vertical straight line. After that we will be creating an arc. So select here 3-point arc, first point, second and third point here in space. Make an arc like this. Now let's select line and make here an inclined line up to this point, and from here select 3-point arc again, first point, second point and third point in space like this. Now select this point and make relation tangent, and similarly select this point, make relation tangent as well. Now select smart dimensioning tool and specify the distance between these two lines as 156 millimeters and the radius for this smaller arc as 12 millimeter, and from this point to this point here specify the length as 75 millimeter, and we are only left with one more parameter, that is the radius for this arc, which is 32 millimeter. Now after specifying all of these, hold Ctrl key, select the line and this arc and here make relation tangent. Now this is fully defined, but we are left with one more thing. Select here line and from this point to this point create a line, and now the sketch has been turned into the gray one. So select here extruded boss base. We want to create the extrusion toward the part in this direction, and here specify the length of extrusion as 8 millimeter and check this box from here. And now select this back face and click on sketch. We are going to make a circle, so select here a circle and find this center point and make a circle at this center point. Now hold Ctrl key, select these two circles and make relation equal, so that we do not need to define any dimension. Select here extruded boss base, and here we need to extrude it in two different directions. The first direction 8 millimeter is fine. Enable the second direction and here specify 54 millimeter the length of extrusion for the second direction, as you can see it from here, the yellow colored material. Okay, now we need to cut a circle here, so select this face and click on sketch. Select a circle and find this midpoint and create a circle here. Now let's specify the diameter for this circle as 42 millimeter, and after that we will cut it. So select here extruded cut and here specify through all, because we want a through hole, as you can see it from here. Now we are left with only two more sketches, so select this section view and select this face, drag it somewhat up here and check this box. Now select this face and click on sketch. I have done this section view because you would not be able to see this corner that I want to make here a corner rectangle. So that's why I have added here a section view. Here specify the width of line as 8 and the length as 50 millimeters, and after that before exiting the sketch, here select the section view again, go to features and select your extruded boss base, and since we want to extrude it up to the surface, so select here up to surface and select this surface. Now we need to simply check this box from here, and since we can see clearly this is a corner which is not good, so select your fillet and select this corner. 10 millimeter radius is fine, and check this box from here. Okay, now select this face and click on sketch. We want to cut two holes where we will be inserting the bolts. So define the diameter for only one, or you can define the second one as well. From this line to the center of the circle, define the distance as 50, and here define this distance as 20, rather define as 25 millimeter. Now from this point to this point of the, or you can say the center points, here define the distance as 65 millimeter. Press escape button. Now hold control key from your keyboard, select the centers of these two circles and make relation vertical so that they can be vertically aligned. And similarly hold control key from your keyboard, select these two circles, make relation equal so that the diameter for both of these circles can be equal. Sketch is fully defined, and here simply select the extruded cut and simply select through all and check the box so that these holes can be available for this part. Now this part is ready for the simulations, so here click on add-ins and make sure that you have enabled the SOLIDWORKS simulation from here by checking these two boxes and click OK. When you click OK, the simulation tab will get enabled. You have to click on this new study only, and here select the static because we are doing the static structural analysis, and this simulation tab will get enabled. Now right click here on the part and click on apply material, and here you can specify any material you like. I am specifying as alloy steel and click OK. As you can see, the color of this part has been changed, which means that material has been applied. Now click on this fixture and select here fix geometry. Since we will be adding the bolts here, so select these two holes. The part will be fixed by these two holes and click OK. And after that click on this external rod, right click here and click on pressure, and we want to apply the pressure on this surface, and the pressure should be inward direction. And here specify the unit as PSI or pounds per square inch, and here define the magnitude as 1000 PSI. Although we can change the direction outward, but I want to keep the direction inward, and check this box from here. Now right click here on the mesh and click on create mesh, and check this box for the mesh parameters, and here define 7 for the mesh parameter. If you specify the smaller values for the mesh, it will take a lot of time for the computation of your computer. So I have specified somewhat larger parameter. Let me show you the detail for the mesh. Here you can see the nodes, which are 16,000. Nodes are basically the points which are interconnected here. So these nodes will be higher when you specify a smaller parameter for the mesh, like 3 millimeter or 4 millimeter. Now click on run the study, and as you can see, the unit is not in PSI. So right click here and edit definition. Here you can specify the right unit, which is PSI, and check this box from here. Now here are the values for the stresses that are being applied on our part, and as you can see, the yield strength, which is somewhat here on our part, and these are the extreme stresses which are on this area and this area. So right click here and click on animate, and as you can see it from here, this area and this area is very critical. And let me show you on the stop view as well. So if you want to visualize in true scale, then you can check this from here, because in actual we used to get smaller deflections like this, and as you can see it from here. And if you want to see the factor of safety, right click here on the results, and here we have the factor of safety, so you can enable it from here, and here define it the same as the stresses. Yield strength is fine for this case, and check this box from here, and as you can see the factor of safety, the minimum value is 0.38. And now let's see, according to the factor of safety, which are the most critical areas for this part. So here select in result advisor the factor of safety, and here I am specifying the same as the type of stresses, and move forward. Here specify PSI for the units, move forward, and we need to select here areas below factor of safety, and simply check this box from here. This will tell us which areas are critical for this part as per the factor of safety. So that's how we can find the factor of safety and the critical areas for our part. So if you find this video helpful, then please subscribe to my channel.